Hi everyone, this is Mohi from Singapore Maths Academy. Welcome back to another 11 plus journey video. Today I'm going to look at another fractions problem, and I want to show you today the power of bar modeling. Some of us may have heard of bar modeling, which is great. Most of us probably haven't heard of bar modeling, and you might be wondering what our most recent advert yesterday was all about. Why is it that we're starting a new bar modeling course in the summer for those who are in year 5 looking at entering grammar schools the next academic year? Well, one of the reasons is because it's so powerful. We're going to look at a question today that demonstrates how powerful bar modeling is. So let's jump onto our whiteboard. And as you can see, I'm using my iPad again. So the question is, how many sixths are there in 3.5? With a question like this, typically, what would we do? We would probably get our kids to think about 6. Okay, and how many of them are there in 3.5? We'll probably convince our children that, well, if I asked you how many 2s are there in 6, what would you do? It would be 6 divided by 2, right? Which equals to 3. And so now we're asking you how many sixths are there in 3.5. How would you write that out? Well, that would be 3.5 divided by 1/6. How would we solve that? Well, 3.5 divided by 1/6, we can kind of think about that and say, well, I know actually, I remember that strategy we used. What was it again? Oh, I know. We'll keep this as 3.5 and we'll multiply instead of dividing the fraction. So we'll multiply by 6/1, the reciprocal of a 6. And then we're going to think about, well, how do I do that though? Because that's a mixed number, right? 3.5. I know I can change that into an improper fraction. 3 times 2 is going to be 6 plus the 1. That's going to be 7 halves. 7 halves times 6/1. Now, some of us may just do 7 times 6, 2 times 1. And then some of us may cancel this down. It becomes 1 and 3. And therefore, 7 times 3 is 21. 1 times 1 is 1. So 21/1 is the same as 21. And so there are 21 sixths in 3.5. Some of us may not know how to do that, or may feel that that's a strategy that takes quite a long time to do, right? So that's one strategy, method 1, right? Another method could be where we think about how to use bar models. You might think, how do I use bar models for this? Well, first thing I would ask my children is, can you actually show me what 3.5 looks like using bars? Okay, so let's do that. That's 1 bar, that's 2 bars, that's 3 bars, and I've got half a bar, so something like that. Okay, the first question is, how many sixths are there in this whole bar? This is my 3 holes and this is my half, so I'm just going to draw this to show the half. And so how many sixths are there, class, in this one hole? I know there must be 6 sixths to make a hole. So I'm going to show you that. I can see there are not 1 6, not 2, not 3, not 4, not 5, but there are 6 sixths in a hole. If there are 6 sixths in a hole, how many sixths will we have in not 1 hole, but in 2 and 3 holes? How many sixths will we have? Well, you can see there's 6 sixths here, and there will be another 6 sixths here, and another 6 sixths here. And so we have 6, 12, 18 sixths so far in the 3 holes. And the final one, half, well, we know we'll have half of 6, which is 3 sixths. We have 3 sixths there. So we have 18, 6, 12, 18 sixths in the 3 holes. And we have 3 more sixths here, 18, 19, 20, 21. We have 21 sixths in 3.5. Now, firstly, because you might be quite new to bar modeling, I've taken my time with this, but I don't envisage children to take too long using the bar model approach here. most children should know by this stage that there are 6 sixths. Ask your child, they might not know. Okay, you'd be surprised how many actually take a long time to remember that there are 6 sixths in a whole. So there are 6 sixths here, another 6 sixths, another 6 sixths, that's 18 sixths, plus 3 more 6, 21 sixths. It's not going to take too long to visualize this using the bar model approach. However, we also not only save time, but we also save the possibility of making some mistakes. Using method 1, there's quite a few technical issues here that some children will face. Like, for example, remembering that dividing a fraction is the same as multiplying the reciprocal of the second fraction. Also, the fact that changing a mixed number into improper fractions, some children might find that challenging. And then remembering to multiply and also simplify. Now, I've simplified before multiplying, so it's a bit easier, so it's 21 over 1. But if you didn't do that, then you have to simplify after multiplying. So there's quite a few technical skills you need as a child. And if you don't have those, then you're going to struggle with this type of question. So that's another reason why the bar modeling approach is really helpful, because it kind of resolves those niggly issues that your child might have, but also it gives children a better understanding of the question. How many sixths are there in 3.5? We can literally show that using the bar model approach. And whilst we're doing that, we save a huge amount of time not going through this method. So I want my children to know that method very well, but we have to also give them an opportunity to decide which would be a more efficient method, which will save me some time so I can use later on more challenging question. That is the question that we have to ask ourselves. So hopefully you've seen the power of bar modeling approach using this example, this one example. If you think that is going to be very useful for your child, please contact us, because we've got an amazing course lined up for the summer, which I know, as someone that has been delivering courses all my life, or professional life anyway, I know that it's going to be very useful for your child, and therefore it's going to help them immensely in their 11 plus preparation. If you want to find out more, give me a buzz, or give us a call, I should say, and also give us an email, and we will love to tell you more about our bar model approach. Take care, everyone. Bye.